So if switch 1 is on, lamp 1 should be on. I'll give it as L1. You are doing it in the same rung.
Yes, yes, madam.
Yeah, see here. Here, can you see 0 represented 0, 1 and 1? Okay. So these are separate rungs. Okay. Whenever you get output, two different outputs. So you cannot start with the two different outputs and you cannot connect two different outputs in the same rung. Okay. There should be one input and two output. That is fine. But not two input and two output like that. Okay. It will show error. So switch 2 on. Lamp 2 should be on. So my first three conditions are satisfied. Switch 1 on, lamp 1 should be on. Switch 2 on, lamp 2 should be on. Uh, Sorry. Switch 3 on, lamp 3 should be on. Okay. Now with the third condition, there is one more condition saying that when lamp 3 gets on, when switch 3 is on, lamp 2 should be off. So now here I'll take one NC switch because I need to off the lamp. Okay. So I will use the address 0.02. Okay. Now this is the second rule. The input address can be repeated at the input side. Okay. Now here we can see whenever I on switch 3, lamp 2 will be getting off. Okay. I'll simulate it now. So switch 1 on, lamp 1 is getting on. Switch 2 on, lamp 2 is getting on. When switch 3 is on, lamp 3 is getting off and lamp 3 is getting on. Is it okay?
Okay, madam.
Okay. So this is the first problem. We'll go for the second one. Which one on? What? The condition. Lamp 1 and 2 should be on. Okay. So, okay. Switch 1 on. Lamp 1 and 2 will be on. Like this, we can connect single input, double output. Not double output, sorry, double input, double output. Okay. So now I'll take switch 2. So now switch 1 on, lamp 1 and lamp 2 should be on, switch 2 on, lamp 3 and lamp 4 should be on, switch 3 on, lamp 5 and lamp 6 should be on. Okay. Now what is the second condition it is telling? Whenever switch 2 is on, lamp 1 should be off, correct? So this is my lamp 1. So here I will connect switch 2. Okay. Next. When switch 3 is on, lamp 2 and lamp 4 should be off. Lamp 2 and lamp 4 should be off. So I will take it here, switch 3. We will run it now. Work online simulator. So it will compile, checks for the error. So when switch one on, lamp 1 and lamp 2 are on. When switch 2 on, lamp 3 and 4 is on and lamp 1 is off. And when switch 3 is on, lamp lamp 4 and 5 are on and lamp 4 is off. Okay, so these two problems are of patterns. Okay, and it will explain the basic rules. Okay, you can connect the outputs only in parallel connection. You can repeat the input addresses. Okay, so whatever the four rules are there, these two will be explaining that. There is one more is also there. Okay, that also is for the understanding the rules of ladder diagram. Okay, got it?
Yes, madam.
Radhakrishna got the output?
No, ma'am.
No, why?
Actually, problem is yeah, red indication will come, ma'am. Actually, in rung area.
Wrong area, red indication will come. I was, see here, wait, I'll show you. Now let's say I connect a switch here like this. Okay, 0.06. See, now for me, and if I connect output here
Yes.
again,
No. Okay.
you also did the same thing, no?
No, ma'am. Actually, I'm doing right, but in
Okay,
this rung place, how many rungs will make? I don't
in one
confuse.
rung, in one, only one thing, one rung, one ladder connection can be make. Okay, see here, for me also red line is coming, no? If I connect output this side,
Okay.
something you have done something like this.
No, ma'am. But actually, one doubt. This one fifth run.
Huh.
Then the next time he go to sixth run, but he's not going continuously.
That you have to take it, Radhakrishna. See, in the see this condition, whatever 0.13 you have mentioned, no? Go up, no?
Yes.
Show your program once, complete program.
Completed, man. 0.12. Actually, fifth rank 23
No,
started,
no,
man.
go up, go up, go up, go up from the beginning. Only this rank is creating the problem.
Yes, madam. From the beginning, okay. This
From
one.
beginning, okay. Okay, come down. See, this condition. See, this one is there, no? You have
Yes.
done one program in one rung. There are three rungs in one program.
Okay.
Now in the fourth rung, you have in the fourth rung, there should be only the first line that is 0.09. The condition is what you have mentioned. No, that should be dedicated only to fourth rung.
Okay.
Okay. And 0.10, 0.11, that is the second line of the program. And 0.11 is 100.7 is a third line of the program. Now, one, two, three, three lines you have written in only one line. Is it correct?
Yeah. No, ma'am.
No, right. Now, fourth rung only should have the first line of the program. So that's
Okay.
why whenever you are writing making a PLC programming, for each program, don't continue like this in a one single file.
Okay.
Okay. For each
Okay.
program, create a separate file. That time it will be clear to you. Now see, how have you done for AND gate and OR gate? Did you created everything in fifth rung? No, right? You have used fifth rung, then you took it to the sixth rung. Correct?
Okay. Oh, yes, ma'am.
Yeah. Please just cut it and paste it. cut, copy, paste it. Okay.
Yes, but time required, madam.
Time required. Okay. Try to solve using truth table. It will be a bit easier. Try to write a truth table for that. Do you guys know to write the truth table?
No, madam.
Okay. I'll leave it as again as a homework to you people. Tomorrow I need the answer. Today, since there are only three students are there, others are absent also. Okay. Uh, we'll continue tomorrow. And regarding the schematic diagram, I saw your people's this thing approach to the problem. Okay. Only none of them are correct actually. Okay. And see, it should not. It doesn't. If it should not. Ladder diagram means it need not to look exactly like the circuit diagrams. Okay. Fewer have taken from the middle and all. Check out the condition how exactly it is working. If you want, I'll give a rough idea. Okay. Now, tomorrow I will explain again. Is it okay?
Okay.
Okay, madam.
Okay. So now see here. Here in this one, the case one, they are using two NO switches. Correct?
Yes.
This is also NO. This is also NO. But this is a open con. This is in off state and this is already in on state. Okay. So this
So,
they have taken output. Correct. If any switch, any push button, if it is in this format, it's if the line vertical horizontal line is above the two rounds, then it is a open. That means it is not yet on. If it is below this two rounds, then it will be in on state. Okay. Initially, it will be in the on state. Got it or confusing? Okay. In the next condition, one is in on state, one is in off state, one is in on state, but one switch is a NO and another switch is a NC. Now, even in the switches, we'll get NO type and NC type switches. Not only in ladder, in the physical switches also, there is NC type and NO type switches. So let's say in your industry, you have given with the NC switch. Now, how are you going to write the ladder diagram using that NC switch? Are you going to use a NO contact or NC contact? Okay, that is very important to understand. Got it?
Got it.
Okay. Now, next is a very simple circuit. It's actually very simple. Okay. Now, 1 second. I haven't mentioned the names. So, this is A. This is B. This is C. This is D. This is E. And this is F. Sorry for the handwriting. Now, see here. Whenever you on switch A, switch B, E will be on. If you on C, F will be on. That much you have understood, I guess. Now, what happens whenever you on the D? Okay. So, whenever you keep on the D, even if when you on A, B, C, any one of them, E will be getting on and F will also be getting on. Okay. You should analyze that what happens. Now, if this is a open, this is an off state, okay. If you connect this one, the circuit will be getting closed. Now current will be flowing. Now what happens if the current flows? That condition you have to understand. Okay. Similarly, this complex one, actually in only name it looks like complex, but this is not complex. Okay. Got it?
Madam, we
Any
got
que-
it, but make ladder, ma'am.
Make ladder, that is your work. I will make
Simple.
ladder tomorrow. If I do it tomorrow, it will be simply waste. Again, they'll be missing the class, no?
Okay.
See, think now when imagine for which and all you will put a NC and NO switches. Okay. Give it a try. Any other doubts? If you want, I will make ladder only for this one.
This
Okay.
one easy. No problem. But
I will also do a easy one only.
actually, problem is your schematic diagram. We cannot easily find out. That's why. Already I
Uh,
make one simple circuit, but that one right or wrong, I think
right or wrong. For which one you did a simple circuit?
simple circuit I already made in ladder diagram.
You did, then you would have shared me, no?
Yes.
Radha,
Okay,
sorry,
ma'am.
one second. Wait, Radhakrishna. Srinivas, I checked yours. Even yours is
Share.
not right. One second, wait. That's why I didn't respond to anyone or anyone's messages that time.
Okay.
Uh, Srinivas. Okay, in your 10th rung, when I on only see, that time only, during that time, E will be on. Okay. In the simple circuit or it's whether in the simple circuit. For E, when I on only C, that time only E will be on. If D won't be on, E will be never on for C. Okay, that's not right. And in the second condition, it exactly looks like circuit. Don't make it look like a circuit. But the last one is correct. But don't make ladder diagrams like that. It's hard to understand. You can repeat the addresses, okay? You can repeat the address. For reducing the address, check it out. How can you do it? Yeah, please try it. Okay, Radhakrishna, continue. What simple circuit you did?
Yeah. Share the screen, ma'am.
You will share the screen. Wow. This is for simple circuit.
Yes, yes, ma'am.
Okay. Let's when I make all the switches are on, parallel connection. See, for 100.03 is E or F.
Yes, ma'am.
Which one is that? This 100.3
Zero three, just
E or F?
just actually 100 dot C. And
100.3
dot 3 means E, ma'am. E.
E.
Uh,
Uh,
E
okay.
coil. Next, F coil means 100.04.
100.04.
Yes, ma'am.
Okay. And now when I make A and B on, A on, B on, okay, E is getting on. Which is D and C here. When I make D and C on, will E be on?
B and C. E. E also be on, ma'am.
Now how are you showing that? Okay, when I make A, D on, F will be on, right?
Yes, ma'am.
And always the current goes upward, it will not come downward. Okay, see here. From 0, from 5, it will not come down to 8. It will be always going up.
Okay.
Okay.
Mm. Means 0.05 or 0.06 parallelly connected. This is
That
wrong.
first only that condition is correct.
That
That
condition is
condition,
correct or wrong?
that condition is correct. Okay, that condition. And when what is this 7 I7 is what? C or D?
C, ma'am.
That only that condition is correct. One is the first parallel connection one, and the C connection one is correct.
Okay.
Okay.
Then B
Now
and D wrong.
B and D is also correct. Okay. What about AD? What about CD? All those things you have to check.
Okay.
Okay. And
Okay.
you have two outputs, so it will ask for two rungs. Okay, not in one rung. Okay.
Okay, ma'am. I will try.
See, don't rush yourself to simplify the ladder diagram now itself. First, use as many as repeat the inputs, repeat the outputs. No, repeat the outputs at the input side. Okay. Take so many, like as much as components you want. Then you will get an idea to reduce it. Okay. You solve today's problem, you will get an idea.
Okay.
Okay. So
Okay.
I will show that one problem. Okay.
Okay.
Okay. Tell me for the first condition, first circuit. There are two NONC, right? But they are push buttons. One is in on state, one is in off state. So what should I use?
NONC, madam.
NONC, correct. So ignore the arrow symbol, okay? So this is push button 1. This is push button 2. This is
Screen not
A.
visible, madam.
It's not visible. Now is it visible?
Yes, ma'am.
Yes.
Okay, see. Now this is push button 1, push button 2, output. This is K. U. Understood the first condition?
Yes, ma'am.
You guys did like this only.